All right, hi class. We're gonna try example number 4 here. We're gonna find the derivative using the limit definition, which is a very common problem for us to do in this section. Let's suppose that the f is a function given as f of x equals 5 times x squared. Find the derivative of the function at x equals 3. That is, they're asking us to find f prime of 3 by using the limit definition of the derivative, right? So I set it up right here, where where we have to find. I added a note here that we're gonna break this process into pieces, just to help us with the process to get a little more familiar. But in the next example, I'm gonna do it the most common way, the most popular way to do it. All right. So again, this is not a normal way to do it, but I'm just breaking it out for everyone. All right. So first, let's go ahead and find what does it mean to be f of 3 plus h. So if your function is given here, right? If you notice, typically, right, this is your x, whatever is input, right? Input is replaced directly in your x. Well, if you notice here, the input is not x anymore in this part, but the input is 3 plus h. Nevertheless, what you're still gonna do is you're gonna input that wherever you see an x. So that means, let me highlight this right here. This right here is gonna go in here, right? The whole thing. And if you notice, I'm going out of my way to put the parentheses. You should, right? We should put the parentheses. If you don't put the parentheses, then we're not gonna get this correct. The reason why we put in parentheses is because this is a group and it must be inputted as a group. All right, so after this, we're gonna go ahead and expand this. Remember, what does it mean? We have, when we have a product with an exponent, we have to first do the exponent. So we have 3 plus h times 3 plus h. That's the definition of a square. And so we're gonna go ahead and expand this and distribute. So we're gonna go and do 5 times 9 plus 3h plus 3h plus h squared. And then go ahead and maybe let's simplify this too. Those can be combined, right there. So we're gonna have 5 9 plus 6h plus h squared, and this is going to go to distribution, boom boom boom. So it'll be 5 times 9 is 45, 5 times 6 is 30, and then times h, and 5 times h squared is 5h squared. So there you go. We found what is f of 3 plus h. All right, and then now we're gonna find f of 3. Well, f of 3 is exactly the same idea, right? Wherever you see, you're gonna replace x with your input, right? Your input is gonna be 3, and so we're gonna replace x directly with 3. So we're doing the same thing, 5 parentheses square. So that means we're gonna plug in 3 in here. So I'm just gonna highlight it real quick here. That number is gonna go here, right? And so we're gonna get a 3, and that's just gonna be a simple number, right? Order operation tells us to do the square first, so it'll be 5 times 9, which is 45. There you go. All right, so we found that f of 3 is 45. All right, so moving on, the next part is to take those two. Oh, I made a mistake here. That's supposed to be a 3. There you go. We're gonna take this, right, and then subtract it by this. So we already have those values. So f of 3 plus h is going to be, and I'm going to put this in bracket, right? So you guys can kind of see that I'm replacing something, followed by the minus, followed by the bracket, because that's going to be that number right there. So this part right there is, according to our notes, 45 plus 30h plus 5h squared, followed by the minus, followed by f of 3, which is 45. Now, if you notice, we can see here that the negative will be distributed to that 45, and that will be negative 45 with a positive 45 will cancel each other out, right? And then we end up getting 30h plus 5h squared, and that's going to be the difference between those two. Perfect. All right, so now let's go ahead and do step number 3. Step number 3 tells us that take whatever we found in the previous problem and then divide it by h. I'll put parentheses here all over h, and there you go. Again, every time you replace something by direct substitution, you have to put parentheses. And so if we look at this, often students get stuck here, like they don't know what's the next step. So what I'm gonna say here is that it's almost routine here. The goal, the name of the goal is to cancel this h, right? Cancel this h from the beginning, but the only way is to be able to do all this process and to get here. So how do we cancel this h? Well, imagine yourself that you are multiplying this by 1. So what you need to do is take the numerator and factor a common h, right? If you notice, and it's gotta be guaranteed that everyone will have an h. So I'm gonna factor the h from the numerator. So it'll be 30 plus 5 times h all over h times 1. And then we come back here, cancel those two h's, and yay, we have canceled the h's, right? And so that's your differences quotient, right? So that's 30 plus 5h. So we have found this part, right? Difference of quotient, which is this right here, right? And that's the last part of the puzzle. So they're asking us to take the limit of the difference of quotient. So I'm going to take the limit of the difference of quotient as h goes to 0. So what is this right here? This right here is, right, this right there. We found it. So we're going to replace that right here, 30 plus 5h, right? And now once you do that, then that's the time for us to apply the limit. Remember what we said, when you apply the limit is a direct substitution, right? Direct substitution of h with 0. So wherever you see an h, replace it with a big 0, right? And that's right there. That was the only h that we had, so that's why we multiply that one by 0. So we end up getting that this will cancel because that's 5 times 0 is 0, and so we end up getting just 30. And that's pretty much it. So we end up getting that that f prime of 3 is going to be 30. There you go. All right. So we'll try this example again in a different way, which is more common, more popular. You guys will have a few examples like this in the homework for you guys to practice. All right. Let me know if you have any questions.